Hello, class. For your third assignment of the week, we're going to be focusing on finding tangent of unit circle angles. And we already have the unit circle, which you, in your previous notes, are going to have a much nicer copy of than this. This is old. But I do want to point it out because I want to remind you that we discussed that the point xy represents cosine of the angle and sine of the angle, cosine theta and sine theta. And that's important because if we're finding tangent of something, we actually have to use those numbers. Tangent is not on the unit circle. It's not one of these points, but we can use the points to find it. So for example, for 45 degrees, I see that the point is root 2 over 2 and root 2 over 2. And so I have something like this. This is the point on the unit circle. Of course, this only works when it's on the unit circle. And so to find tangent, I know that on the unit circle, whatever the angle is, I've got my y and my x, and I know that tangent is opposite over adjacent, and so that's y over x. And since y is the same as sine and x is the same as cosine, that means that tangent is sine over cosine. When you get to pre-calc, you will probably be doing that a whole bunch. You're going to see that a lot. And so what I'm going to do is this is going to be my x, and this is going to be my y because it's xy, and that's cosine and sine. And so to find the tangent of 45, which we don't write tangent 45, we write tan 45, but we pronounce it tangent. I'm going to write the sine, which is here, root 2 over 2, over the cosine, again, root 2 over 2. And there are two ways to look at this. One is that any fraction that's exactly the same on the top and the bottom equals 1. And the other way is to actually do the arithmetic. I have root 2 over 2 divided by root 2 over 2. When you divide fractions, it's the same as multiplying by the reciprocal. Everything's going to cancel out. Remember rational functions from way back in February when life was so easy and we were allowed to leave our houses, and we still get a 1. And so I can say that tangent of 45 is 1. That never changes. Tangent of 45 is always going to be 1, no matter where you are, what triangle you're in. If you have 45 degrees, the tangent of that is 1. I want to look at what the tangent of 30 is. That's a little bit more difficult. There's my arm. And this is my point, root 3 over 2 and 1/2. And so my sine is 1/2. That's that point. And cosine is root 3 over 2. That's from the point. And so now I'm actually going to do the division, the fraction division. 1/2 divided by root 3 over 2. And this is good practice with dividing fractions. That's really the same as 1/2 times 2 over root 3. And those 2's cancel out. That's nice for us. And I get 1 over root 3. But one thing that I've learned through teaching pre-calc is that apparently, at least on AP test, if you're planning on taking calculus at any point, you are expected to rationalize your denominator. You are not supposed to leave it like this. I really think it comes from the days of when they used to use slide rules. And in a slide rule, you have to have every unit and whatever row you're on has to be the same. And these are not linear. And so they're not rational, and so we have to rationalize it. You can't have a root in a denominator because I think this comes from the days before calculators. 1 times root 3 is root 3. Root 3 times root 3 is just 3. And that's the tangent of 30. And so we have tangent of 30 is root 3 over 3. And then I want to find the tangent of 60 degrees. I know that the point for 60 degrees goes the other way. It's 1/2 is the x and root 3 over 2 is the y. And so I'm going to set that up. Root 3 over 2 over 1/2. when I do the fraction division, I have root 3 over 2 divided by 1/2, which is the same as root 3 over 2 times 2 over 1. Well, in this case, the 2's cancel out, and when I multiply straight across, I just get root 3. So tangent of 60 equals root 3. I'm going to do a couple more with you, and then we're going to look at tangent of some of the other angles around the unit circle. Although I believe that your practice should just be the first few angles, but I'm not sure 100% because it's IXL and you never know what you're going to get. We'll look at the tangent of 0, and I also want to look at the tangent of 90. So the point for 0 is 1, 0, and the point for 90 is 0, 1. Well, my y is 0, and my x is 1. Any fraction that has a 0 in the numerator is just 0. And so tangent of 0 equals 0. Yay! Now with 90, the y is a 1, and the x is a 0. Now, this is different. These two are very different fractions. This fraction equals 0. This fraction does not equal 0 because you can't divide by 0. There's no number that if you multiply it by 0, you're going to get 1. And so what we say is that the tangent of 90 is undefined. So tangent of 0 is 0, but tangent of 90 is actually undefined. It's different because the 0 is in the denominator. 0 is in the denominator do not mean 0. It means undefined. I'm going to turn the page, and we're going to look at how we can use this information to find the other ones. So first I'm going to write a little summary. I have tangent of 0 is 0, and tangent of 30 is root 3 over 2. Tangent of 45 is 1. Tangent of 60 is root 3. And tangent of 90 is undefined. How does that help us? Well, when we go back to that unit circle, let's say I want to find the tangent of 150. Now I know 150 is in the second quadrant. It's here, and I know that x is negative and y is positive, and I also know from a previous video that 150 and 30 make the same triangle, which means I look at the x and the y coordinates. The y coordinates are identical, and the x coordinates are opposites, right? For 30, it's positive, and for 150, it's negative. That means the tangent of 150 is based on the tangent of 30, but because one of these two values is negative, I'm going to have a negative thing. Oops, that's root 3 over 3, not root 3 over 2. It's going to be the same, but negative. So not the same, it's going to be negative. Negative root 3 over 3. Because x is negative while y is positive. So it's going to be the same as 30. If I want to find the tangent of 135, I notice that 135 is also in the second quadrant, and it's the same triangle as 45, except for that x is negative. And so because of that, it's going to be very similar, but because one of the values, the x value, is negative, in this case, instead of being a positive 1, it's going to be negative 1. That's how we use the unit circle and these values right here to find tangent of all the other angles. We use these angles and the x and y coordinates of these angles to find the sine and cosine of all sorts of different angles. And now we can also use the unit circle and these angles to find the tangent. So for example, if I wanted to find the tangent of 300 degrees, I look for 300. It's here in the fourth quadrant where x is positive and y is negative. And I know that 300 is the same triangle as 60. It's a very similar triangle. It's actually exactly the same triangle, but it's in a different quadrant. And so because x is positive and y is negative, one of these two values is negative, it's going to be very similar to this, except negative. If I wanted to, for example, find the tangent of 225, I know that 225, well, I know, you might need to look this up, is in the third quadrant, and both x and y are negative. They're both negative. And so it's a very similar triangle. It's the same triangle as 45, which means the tangent is going to have a 1 in it because both of them are negative. A negative divided by a negative is a positive. And so the tangent of 225 is 1. It's actually the exact same as 45 because I have two negatives. A negative divided by negative is positive. I can also find that, let's say, for 210 degrees. That's also in the third quadrant. I know that 210 is the same triangle as 150, which means it's the same triangle as 30. And so, except that our values are both negative. Because they're both negative, I'm going to have a very similar tangent, except for it might not be positive, except for we have a negative divided by negative again. So it's actually exactly the same. Whereas if I were to go to 330, for example, also the same triangle as 30, because x is positive but y is negative, when one of the values is negative, the tangent is going to be negative. If both of them are negative, the tangent will be positive. And so a good way to think about it is we've got positive tangent here and negative tangent here. I'm going to give you some IXL problems for you to try. You need to do at least 15 of them or until you reach 80%. So in order to get full credit, you need to get 80% or do at least 15 problems. I say 15 because they go by really, really fast. There's not a lot that you have to do, and it should only say sine, cosine, and tangent. If it says more than that, then please let me know. But when I tried the problems myself, I kept on going. I think I was up to like 16 or 17, and it was still all sine, cosine, and tangent of all of these same angles. If you have any questions, please come to our class meeting on Tuesday at 2:15. And otherwise, you can also private message me. And I'm not sure if we're going to have class on Thursday yet or not. I will let you know. But for sure, Tuesday at 2:15. And otherwise, have a great week.